In this section, we'll be looking at when a trig function is even and when a trig function is odd. Let's go ahead and review the definition of an even function. We say that a function f of x is even if f evaluated at negative x is equal to f of x for all x. And we say that a function f of x is odd if f evaluated at negative x is equal to a negative f of x for all x. With this, let's just go ahead and state which trig functions are even or which are odd, and then we'll prove it. So number one, sine, tan, cosecant, and cotan are odd functions. And number two, cosine and secant are even. Let's go ahead and prove number one, sine is odd. If we evaluate sine at negative theta, then by the definition of sine, using the unit circle, this is going to be equal to a negative y divided by r. Since our definition used the unit circle, which means the radius was equal to 1, this is the same thing as just negative y. Now, negative 1 times y can then be replaced with negative times our sine theta. And so we have our sine is odd. Now we can also go ahead and prove that cosine is even. Well, we can do the same proof that we just did. Let's just go ahead and prove this one graphically. So number one, we know that our cosine function looks like the following. So this is from 0 to 2 pi. And then from negative 2 pi to 0, our function looks like the following. So this is our cosine of theta. Now, if we wanted to look at cosine of negative theta, then hopefully our function would look exactly the same. So recall that when we apply a reflection along the y-axis, everything on the right hand goes to the left-hand side, which means we're going to map the blue part of our curve to the following. And then everything on the left-hand side goes to the right-hand side, which means we're going to map the red piece of our curve to the right-hand side. So graphically we see that we should get the same function, we're just switching where the x values are going. So this proves graphically that cosine is in fact even. Since we have sine and cosine are even, this implies that our cosecant function is odd, because recall that cosecant is equal to 1 divided by sine, and we also know that secant theta is even because secant theta is 1 over cosine, which means the only functions that we have to worry about proving now is tan theta. So we need to prove that tan theta is odd. Recall that tan theta is equal to sine theta divided by cosine theta. Then let's go ahead and show that tan evaluated at negative theta is equal to a negative tan theta. So this will be equal to a negative sine theta divided by cosine of negative theta. Since we know cosine of negative theta is even, this then becomes cosine of theta with a negative sine theta up top. But this is equal to a negative tan theta. And so we have just shown that tan theta is odd. Let's go ahead and look at one more example, example 4. And we want to determine if the following is either even, odd, or neither. The easiest way to do this is, again, evaluate your function at negative x and just see what happens. we get that this is going to be sine evaluated at negative x and cosine evaluated at negative x. Sine evaluated at negative x, since we know sine is an odd function, can be rewritten as negative sine x. And since cosine is an even function, cosine can be replaced with just cosine of x. This will be equal to a negative sine of x times cosine of x, and this is equal to negative f of x. So this function is actually odd.